what is Arduino IDE and what is the introduction to the Arduino IDE? We'll also look a glance about what are the settings and what are the features available in Arduino IDE. Along with that, the features will try to do an program. So we'll try to execute a program for a 4-lane graphical control system. So we'll be using different LEDs and we'll be using an Arduino board. So we'll be trying to do a project. Along with the project, we'll try to execute the program and as well as find the output. So let's get started into the video. So meanwhile, when I open this Arduino, so let me just brief about what is Arduino. So Arduino IDE is nothing but the integrated development environment. So it is very easy to use and it can be downloaded in Mac OS. It can also be downloaded in Linux as well as Windows. So in this IDE, so we are able to write various program embedded codes and we are able to do the programming. So and we are able to execute as well as fetch the output. So it has an inbuilt library as well as various sensors can be added. So various sensors libraries can be added into this IDE. Also, it supports the real time as well as the various boards. So we can execute programs for different boards such as Arduino Uno, Arduino Mega, Arduino Nano, as well as other boards such as ESP32 as well as ESP8266. So the language, if you ask me, the language used in this particular IDE is either C or C++. So we'll be using embedded C, that is it's the simplest program to write any program in action for finding the output of any microcontroller. So usually companies of it usually comprises of a text editor where we'll be writing code, and it also contains a console window and also a toolbar. So it also has serial monitor, so we'll be getting the output. So in the serial monitor, we'll be getting output as well as see the output range of sensors, so we can finally finalize the output range. And finally, if a user is trying to write in this Arduino IDE, then it's very simple and it's very easy to upload to the microcontroller. Once the program is uploaded and dumped into the microcontroller interacts with the GPIO pins, that is the general purpose input output pins of sensors, and it fetches the output. So if you will ask me what is the difference between Arduino and Raspberry Pi, Arduino is a microcontroller while Raspberry Pi is a mini computer, but it's a microprocessor. Now we'll discuss about this Arduino IDE, but Arduino IDE has many inbuilt programs. So if let's assume like if there is any coder who doesn't know how to code or who have started a career with Arduino, then it will be very easy for him or her because it has inbuilt programs which can be considered and which can be used to get the output. So if you want to know how to download the Arduino IDE as well as how to install it into your system, that will be a separate video which will be mentioned. So let me know your comments, put down in the suggestions, and let me know if you need that video. Then we'll surely come up with that video. So I have personally liked this the section as well as I have already liked and have done various projects on this particular IDE, and with my personal experience, it's an go to go and it's very easy and it's a easy tool. So I had started without any prior knowledge on the coding. So doing the projects on this particular IDE made me stronger in this embedded system. So hope so even it makes you the stronger person as well as you will be able to do various projects on embedded systems. So let's get started to the direct video. So if you see, this is the after opening this the Arduino IDE, which is open, that is integrated development environment. So first of all, we go to the file and we go to the new. So in new, we'll be getting the new file. So we just open it up. As you can see here, already a setup is provided, that's void setup as well as void loop. So we'll be explaining how to write in code in detail. So as of now, let's just minimize this and just delete this part. Okay. So as you can see, there are the different sections in the toolbar, that is the file, edit, sketch, tool, and help. So we'll be discussing about the recent one and which is most useful. So if you go to the files, you have new where you'll be able to fetch a new program or a new file where you'll be able to write the console program. We have open, so if you have any program which is already saved in your system, you can open that but using this particular option. We have open recent. This will show all the recent projects that you have done. So these are some of the recent projects which I have done recently. Similarly, you have the examples. So this is the inbuilt examples which I had talked about. You have various examples like basics. You have basics of analog, read, serial. You have blink, so it is for an LED. You have analog read for voltage, digital serial. You also have digital analog communication control sensors. So sensors like ADXL sensor, that's an accelerometer, and various other sensors. Also, you have strings, you have USB, you have Arduino ISP. So you have so many inbuilt libraries over here and so many inbuilt examples. For example, if you want to open any example, just you have to go here and just click on this option and you'll be getting the code. And directly with the code, you can compile and you can just upload into the microcontroller and the work is done. Now, if you talk about the other one, it is save and save as. So as you know what is save and what is save as, and we'll go to the next option that is preferences. So why do we need preferences? So we think we are using Arduino IDE and we need an Arduino Uno board or an ESP8266 or ESP32 board. So when we are using this board, what happens is like we need to know all these things and all the libraries of this particular board has to be initiated. So how to initiate the libraries of this particular board? So we initiate in the preferences. So as you go to the preferences, as you can see, this is the pop-up window that opens. So I already have installed this particular package, that is the library package for ESP8266, ESP32, as well as Arduino Uno. So if you are new to this particular system and if you are new to this particular field, then what you can do is like you just have to go to the Google, and when you go to the Google, you just have to type Arduino board GitHub. So usually GitHub is the trustworthy website. So we go with GitHub. You just have to type Arduino board GitHub, and you can see the first link, that is Arduino open source electronics platform GitHub. Just open that, and once it is open, all you have to do is like you just have to download this code. Along with that, if you just go down this website. Yes, guys. So as you can see, you have this particular web link for this particular website. So this web link for this particular website is HTTP. Yes, as // dot. You have this particular, as you can see here, you have this particular link. So what you have to do is that you have to copy this particular link. Just after copying this link, you just have to go back to the Arduino IDE platform. And once you go back to the platform, you just have to put here. So as I have already added some, if I want to include this library, I just have to put a comma. Then I just have to, after putting a comma, I just have to paste it. So it's all done. And once it is done, you just click on OK. So once you do this, all the boards, packages, and libraries of this particular board will be installed and you'll be able to operate it. Now, if you go to the edit part, there are no as such features that should be explained. When we go to Sketch, we can see upload. So when we want to upload the code, we can click on this, or there's a direct option which we'll be discussing later. So we also have include libraries. So these are the library files which are already available for some of the sensors. So various sensors are available and various libraries are available. So if you are using various sensors, you can use various libraries. In case you don't have any library for any particular sensor, what you can all do is like you just have to click on this manage libraries and a screen opens up, as you can see. So it might take a little time. So let's just wait for that to happen. Yes, guys, so as you can see, this is the particular window that is opening up. So in this pop-up window, what you all have to do is like once it loads, you just have to search for the sensor. So for example, today we'll be doing about a project that is traffic light controller. So we need Arduino Uno and we have LED, right? But we don't have any sensors. Let's take an example of a gas sensor. So for a gas sensor, I need gas. So I'll type here as gas sensor, as you can see, and that's it, gas. That's it. After just searching, you can see various examples. So here you have one by Adafruit, one you have by uh, the various packages and various libraries have been included. You can just choose, you can just read the description and choose the right one. And what all you have to do is just you have to click on install. So once it is installed, you'll be able to get the library and you'll be able to code easily. So libraries are just the header files, that is the .h files which are added to your preprocessor directives, which helps in the definition of the code. And along with this, you can see here you can upgrade as well as downgrade this particular version. And once it is done, you just have to close this window. This was all about your sketch. Now what we do is like we go to the tools. So in tools, what we happens is like, for example, we have when we are connecting this particular board to this connector, that is the adapter connector, which is should be connected to the Arduino. So you can see here board managers. On this board manager, you can choose Arduino Uno or Arduino Mega or Arduino Nano. So the various boards available, as you can see. When we can find boards for ESP32 as well as ESP8266 and various other boards, as you can see in this entire list. In case there are no boards which are available and we are not able to find Arduino Uno, what you can do is, for the fresh users who are using for the first time, they just have to click on this board manager. So when you just click on this board manager, this window opens up. So just wait for this guys so that it can be loaded. Yes, as it is loaded, now we need to find for Arduino. So let's just type Arduino. So guys, as you can see, there are various packages available for this particular board, that is Arduino. So this is the one which I have already installed. So in this package, you can see Arduino Uno, Arduino Wi-Fi, Arduino Nano, Arduino Mega, and various other boards. So what you have to do is that you have to click on the install, and if any new version is available, you just have to update over here. So once it is installed, you just have to close this particular pop-up. Now once it is done, then you can see the board will be arranged. Then here you have, when you're connecting your board microcontroller, you just have to select which microcontroller board you're using. Then when you're connecting your adapter to the data cable, that is the adapter of the Arduino to the port of your laptop, what happens is that this port will be enabled. As of now, as you can see, this is disabled as I have not connected any data cable. So when you connect the data cable, you will be able to detect the port, and you just have to select the port, and it's done, guys. So once for every code, whenever you have to make sure that whenever you write a code, you just have to, all the time, just have to select which code you are selecting. After selecting the code, you have to choose the code, and that's it. So once it is done, what all you can do is, like, you just, the code will be ready. Then this is your uh, compiling compilation. So you just have to click here. So the code will compile, and if there is no error, then it will be showing done compiling. And if it is error, it will show the error. So once you double click on this particular error, it will lead you to which line you have error, and subsequently you can resolve the error and find it and debug the errors. And this is the upload option, guys. So when you have to upload, either you can click here, or you can go to sketch and click on upload over here. So once you click on upload, what happens is that the code will be ready. The compiled code, which doesn't have any error, will be executed, and it will be fetched, and it will be executed onto the microcontroller. Microcontroller communicates with the GPIO pins, that is general purpose input output pins of the sensors, and we get the desired output. So as you can see, guys, this is in this screen. So this is your serial monitor. So what happens in the serial monitor, you just have to click on the serial monitor, and as of now it is not opening now because we haven't created any code. So once any code is ready, you just have to click on this particular serial monitor, and in this particular screen you will be able to find the output. So this is all about the introduction to the Arduino IDE. So let's do a project that is like four lane traffic control system using LEDs and Arduino. So before that, I'll just explain you how to write in code. So for example, if we take an example code, as I had told you, if you go to files, examples, and we'll take an example for, yes, we'll take an example for LED. So as you can see, guys, this is the code for LED. So it is very simple. So as you can see the code, so these are the parts which are not required, which you can delete it. Okay, as you can see, this is the void setup. So usually it consists of an initialization. So there is no initialization. So in what happens in initialization is that you initialize the pin, you initialize which pin should be assigned for what pin number. So for example, you have a you have a humidity sensor. So humidity sensor will have various pins like VCC, ground, and the data pin. So VCC should be given to which pin, data pin should be given to which microcontroller pin, and the ground should be given to which pin of the microcontroller. So these are the information which you give in the initialization. Next is your setup. So as you can see, this void setup. So it is all about your void. So what happens in void is, like, as you can see, guys, in this particular code void setup, you just have to write the pin mode. So you just have to assign whether the particular pin or the pin number which you had assigned is the initialization is output or input, that is logic high or logic low. And once this initialization of the output or input is over, then you can uh, set the baud rate, that is baud rate of 9600, 11000, 5200. So these are the two baud rates which are commonly selected for any of the projects. So baud rate, why we have to set the baud rates? Because it is a number of bits which will be transmitted per second. Along with that, we have serial dot print. So in some codes, we can see here a serial dot print. So why do we need serial dot print is because, as I told you, we have the serial monitor over here. So as you can see, we have the serial monitor. So when we open the serial monitor, we'll be able to detect the output, but we are not able to, and we are getting error because we haven't compiled this program yet. So once the compile is done, once the uploading of the particular program is done, then we click on the serial monitor, we'll be able to get the output. Okay. So then next is your loop. So when you go to the void loop, what happens is like you just set the spin whether it is high or low. When so you're writing digital, right? So example, you take LED. So LED is nothing but digital writes because it is getting the information from the microcontroller or from the system, and it is performing its action. So it is an digital sensor. And if you talk about analog sensors such as gas sensor, what happens is that it has to detect the gases from the atmosphere, and after detecting the gases from the atmosphere, it has to perform some action onto the system. So that is an analog sensor, but LED is a digital sensor. So as it is a digital sensor, as you can see, it is digital, right? And we are setting it as a high pin or a low pin. So when once it is high, the LED will be on, and we are giving a delay of 1000 milliseconds. That is nothing but 1 second. And after that, we are again making the pin of this microcontroller for the LED as low. So the LED will be off, and we are giving again is the delay of 1000 milliseconds. That is nothing but 1 millisecond, 1 second. So after 1 second, what happens is there will be parenthesis closed. So it means that your program is getting ended over here, and the program will fetch the output and it will go out of the loop. So there are two types of loops, guys. So if we talk about the loop, we have the for loop as well as we have the while loop. So why do we have the for loop is because, so for example, if I show you, so uh, if I go to the new file, okay, yes, guys. So we have, if we go to the section called as loop, so we have usually different kinds of loop. So what are the different kinds of loop we'll be discussing now? So first is our for loop. So what happens in a for loop is that if we write, for example, for I equal to 0, semicolon, I less than 5, semicolon, I plus plus. So guys, what it usually does is that it understands the code and it checks the code. So after checking the code, what it does is like it start the value of I from 0. After starting the value of I from 0, it will be I less than 5. So it will count for 5 times. So the sensor values will be printed onto the serial monitor for 5 times. And this is I plus plus, that is the increment operator, so that once I is 0, this increment operator will be performed and I will be next one, then 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So, and this particular code will end at 5. And this is the particular example for loop. Similarly, we have a while loop. So what happens in a while loop is, guys, that in while loop we just like write a simple code. So what happens in the while loop is like we just write while in the bracket 1. Yes. So what happens here is like we are not setting any count here. So directly all the sensors value will be keep on printing for infinite times until we manually stop it. So until we manually stop the sensor from operating, it will be keep on printing the values. But here, if you come to the for loop, it is like we are set a count of 5. So it will only repeat to 5 times. After 5 times, it will automatically close. So this was the two types of for loop. Now what we'll do is like we'll try to write the example for this particular code which we are doing. So as I told you, we'll be doing the project on 4-lane traffic control system using LEDs and Arduino. So let's take an example. So I already have the written the code, so I'll be just presenting this code and I'll be just explaining the code. So and we'll be doing a live demo of this particular project. So we'll be opening. So have saved the guys, saved the project in my system. So I'll go to open, then I'll search for my code. So we can search in which location we have set it, and I'll be going to that particular code. So this is the project, guys. So this we have to double click and the project is code is ready. As you can see in this particular project, so we have set int lane 1, int lane 2, int lane 3, and int lane 4. We have initialized 4 lanes, and we have set a square bracket. And so why do I have set a square bracket? Is that in the square bracket we're writing which LED to operate. So if it is 1, 2, 3, 4, it means that the count of 1, 2, 3, 4 is nothing but the LED count. So int is the integer type which you are setting for this particular lane, so that the output comes in an integer or data type. So data types you'll be knowing if you have studied C, and you'll know what is int. And we have set the initial the pins. So we have set lane 4, the LEDs as 2, 3, and 4. For the lane 3, we have set the LED pins as 5, 6, 7. For the lane 2, we have set the LED pins 8, 9, 10. And for the lane 1, we have set the LEDs 11, 12, 13. So we have set three different LEDs in this particular code. But while we do the project, we'll be using 4 LEDs, and we'll try to find the output. As you can see, this was all about initialization. After initialization, next process is your setup. So as in setup, we are using for loop. So in for loop, what happens is that int value of this particular I should start from 0, and we have given I value less than 3 because we have to get values, 4 values, that is 0, 1, 2, 3, 4. That is not totally 4, but as it is starting from 0, we are giving I less than 3, and increment operator, that is I plus plus. And here, as I had told in earlier, so we'll be setting the lane and different position of this particular pin as either output or input. So we have to glow the LED when the operation is happening. So that is an output, as you can see. Then similarly, we have even certain again for loop for different values of I, and once it is done, we go to the for loop. So in this particular loop condition, what happens is that we can either use for loop or we can use while loop. But in this particular code, as you can see, we have written digital write. So as you know that LED it gets the information from the microcontroller and it operates and it glows. So it is a digital sensor. So we write digital write. If it was an analog sensor such as gas sensor, we would write analog read. So that is the difference between analog read and analog write. Sorry, digital write. So we are writing digital write here, and we are setting different lanes. So lane 1, lane 2, lane 3, and lane 4. And we are setting in the square bracket 2, 0, 0, 0. So 000 is the count value for different LEDs, and 2 is the LED count for this particular thing, and we are setting all as high. So what happens is that only the second LED will be high, and the remaining all 3 LEDs will be high. But as it is 0, no LED will be glowing. Then we have set a delay of 7,000 milliseconds, that is nothing but 7 seconds. Similarly, the same operation we have done for different other lanes of, that is lane 1 and 3, and we have already set a delay of 3 seconds. We have done the same setup for lane 1, 3, and we have set a delay of 7 seconds. Similarly, these are the different setup which we have done, and we have set various delay set things. So if people want this code, I'll be mentioning this particular code in the description down below. So you can just click on this description link and you can download this particular code and you can try to execute this program in your house. So uh, so once this is done, you just close the parenthesis. So what happens is that it comes out of the for loop, and the program understands, okay, it is the end of the program, and the output will be displayed till this particular parenthesis. And once this code is ready, you just have to compile this. So you just have to click here. So it will start compiling. So as you can see, it is showing compiling sketch. I will wait for some time until it is compiled. So it is taking a longer time. Sometimes it takes a longer time depending upon your CPU speed. So as you can see, it is showing an error. So because I have done the code and there's error because I haven't decoded the errors yet. So you can search here. So if you want to search the error on which particular line, what you can do is that you just have to drag this and you just have to click on this particular board. So the error, there is no error on any of the lines, but the error is that the error for compiling board, you know. So what it means is that you haven't selected your board. So what you have to do is like you just have to click on tools, you have to click here, and you will be getting Arduino Uno. And as you can see, guys, I haven't connected the data cable to the port of the laptop, so it is disabled here. So that's why, that is the main reason I'm getting this particular error. If I have connected this particular data cable to my port of the laptop, the port will be enabled and I'll be able to select the code and there would not be any error. So once the error is compiled, what you have to do is like you just have to click on this option, and this particular code will be dumped into a microcontroller, or it will be executed onto the microcontroller, that is your Arduino Uno. And finally, you can click on the serial monitor once it is done, and after clicking on the serial monitor, you'll be able to do the process, and will be able to find the output on this particular serial monitor, that is the particular screen. So if we talk about our project, that is 4-lane traffic control using 4 LEDs and uh, your Arduino. So as you can see, guys, so first of all, these are the components which we require. That is, one is the Arduino Uno, next is LED. So totally we need 4 LEDs, and there are 4 lanes. So so we'll be using 3 LEDs in this process, and we have 4 lanes. So 4 multiplied by 3, that is 12. So 12 number of LEDs we need. We need jumper wires, we need breadboard, and we need a multimeter. So why do we need jumper wires? Why do we need multimeter? So this will be a separate video, and I'll be explaining you what is multimeter, how does it function, what are the various functions of my multimeter. They'll also explain you how to check the continuity of wires. So sometimes what happens is that the code is ready, the code is correct, and there is no errors, but still does not get any output. That is because there might be any loose contact, or there might be cut between the wires, so the current is not able to pass from one end of the wire to the other end of the wire. So we have to check the continuity of the wire. So this can be done using multimeter. So that will be showing in your next video. So these are the components which is required. Now, if we talk about the block diagram, so as you can see, guys, this is a block diagram. So we have your Arduino Uno. In Arduino Uno, the pin 2 to 4 are given to these 3 LEDs. That so we are using 4 lanes. So it's lane 1, lane 2, lane 3, and lane 4. So each lane is having 4 LEDs. That is, one is red, one is yellow, one is green, and one is blue. So all lane are having the same color of LEDs. So what happens is that the pin 2 to 4 is given to 3 LEDs. The pin 5 to 7 are given to 3 LEDs of yellow. Pin 8 to 10 are given to 3 LEDs of green, and pin 11 to 13 are given to 3 LEDs of your blue LEDs. Finally, what happens is that after setting up this thing, you'll be connecting the data cable from the Arduino Uno to the laptop port, and finally you'll be uploading the code as well as compiling the code. And as you can see in this particular block diagram, that is the rough block diagram, you can see all the LEDs are connected to a common ground. So usually an LED will have a positive terminal as well as a negative terminal. So all the negative terminal will be given to the ground of this particular board, and all the positive supply or the positive pin of this LED will be given to the pin configurations of this particular Arduino Uno, because when you are powering up on this Arduino Uno using the data cable, power is already delivered to the particular board, and you just have, as the power is already delivered, there is no need to connect the LED directly to the voltage in the supply, but directly you can give to the pin configuration. So once this is done, we'll discuss what is happening in this particular project. So as you can see, guys, so this is the traffic light system. We are using 4 LEDs. One is green, one is red, one is blue, one is yellow. So these are the 4 LEDs. You, as we had explained in the code, that is lane 1, 0, lane 1, 1, lane 1, 2, lane 1, 3. As you can see, all the lane 1, 2, 3, 4. These are the different lanes which are available, which we are writing in this code, and the number which we are writing in the square bracket. As you can see, 0, 1, 2, 3. Those are the LED counts. So the LED 0 means LED 1, LED 2, LED 3, LED 4. So as you can see in the block diagram, we had used 4 LEDs. So these are the count for 4 LEDs. Now, once this is done, we have already picked up the circuit for this particular project. So the source code for this particular project is already available in this description down below. And if you need how to connect this thing, so it is a very simple program, because we have showed you the block diagram. So just depending upon the block diagram, you just have to connect all the wires and the sensors. In case if there is any issues and you are not able to do the rigging up of the circuit or wiring up of the circuit correctly, you can mention us down in the comment section, so that we'll be making another video how to do the connection for this particular project. So we have already rigged up the circuit, and we have wired the circuit, and we have tried to find the output. So we'll be showing you the live demo how we have done. So till the live demo, stay tuned.
Yeah, hi guys. So as you can see, this is the program for four-lane traffic controller. So four lights will be there, which will be like on four traffic roads cross section. So this is the entire program which we have typed here. And coming to the circuit, we have connected all the four LEDs, like three LED, like red, green, blue, to one side. Like four times we have connected totally 12 LEDs. We have connected 12 resistors, as you can see, and from the resistors positive supply we have given to the Arduino setup, as you can see here. So Arduino to the pins from starting from 0 to 13 we have given all the pins. Now what you can see, as you can see, now we have given a delay of 500 seconds as well as 1000 seconds, that is by the 1 second as well as zero point 0.5 seconds alternatively. So as you can see, the lights will be changing one by one. So on the four lanes, as you can see, color is keep on changing. Now it is, as you can see,